In this video, we are going to see about the paper titled Deep Reinforcement Learning at the Edge of the Statistical Receipts. So, it is one of the best paper in 2021 in NIPS. And this paper is about the necessity of uncertainty quantification for evaluating the performance of the deep reinforcement learning. So, let us see an overview of what this paper is says about. So currently, many deep reinforcement learning algorithms performance are usually estimated using a point estimate like mean and median, using a very few number of independent trainings. Where it's because for most of the things, the every run per task is seems to be a computationally expensive. But unfortunately, the statistical mean theorem requires more runs for giving an unbiased estimator and also to reduce the uncertainty. But for us, like a reinforcement algorithms have a computational probability for more evaluations. So either it has to go for other way to evaluate it, or we have to uh, uh, go along with the uncertainty, statistical uncertainty. So, but if we are trying to ignore this statistical uncertainty in evaluating the deep reinforcement analysis, can give like kind of a false impressions in further progressions in the field. It won't end up in a robust control framework. So that we will be seeing here in a brief way. So in this work, what they try to say is in for reinforcement learning where evaluations are very expensive, so statistical uncertainty prevails and it's very predominant. And in order to overcome those things, there should be certain other ways to quantify this uncertainty. So the bigger question is how do we evaluate the performance of this reinforcement learning? Probably only if we are having a few handful of runs. So that's why it comes here that point estimates are replaced by interval estimates, and there are also other ways to evaluate the performance like using for identifying the performance distributions across various tasks. They use performance profiles, which we will be seeing very briefly in a pictorial way. And also finally they use interquartile mean for robust evaluations of their performance in the reinforcement learning tasks. So this is a table summarizations for what this paper has been done for. For uncertainty measure, for instance of point estimate, they are recommending stratified bootstrapped confidence intervals. For measuring the variability in the performance across tasks and friends, they are recommending the performance profiles where it's a score distribution where we only will going to see about the pictorial representation, and also to measure the metrics, aggregate metrics across all the tasks. So they are recommending a specialized mean called interquartile mean. So on the section 3 is about they are done certain benchmark on other this reinforcement learning task, and they found that when they are doing a point estimate, it seems to be uncertainty where the different number of runs are going, different samples are done, and there will be a distributions keeps varying significantly, and the median estimation is also unpredictable. So there is a high variability in the results, and also it's a very biased estimation. So if we have only a few runs and we try to estimate it, normally it does not what normally we try to go for an unbiased estimate, but the biasness is very severe here, substantial bias here. So in order to address these few runs for few evaluations, what they recommended is go for estimating an interval estimate that is called as using a stratified bootstrapping method. So this is one of the things they are doing. The other thing is going for a performance profile across various tasks and various runs. That's what it describes in Figure 7. So I'm going to give an overall brief view here, but this video is about overall giving a brief overview of this paper within a 5 minutes. So the other third way to go is to go for a interquartile mean to make an estimate for the aggregate metrics. So they have proposed these three different uncertainty quantifications methods. and they evaluated in certain benchmark tasks and found satisfactory results. So that's what this paper is all about. Hopefully, we may try to put another video to see how each and every that stratified bootstrapping of intervals or performance profiles and aggregate medicine interquartile mean, what does mean, and what is the background of that statistic behind those things, and how we also try to see that graphical views of the results, but not in this video. This is overall idea about this paper, which is awarded as a best paper in 2020. Hopefully, it will come up in next video. Thank you.